Hello everyone, I am Jagan. In this video, we will be learning about IEEE 802.11 standard. First, I will introduce about IEEE standards, then I will explain in detail about IEEE 802.11 and its types. Before going into the topic, we need to know what are standards. Why do we need standards? Standards are published documents that establish specifications and procedures designed to maximize the reliability of materials, products, methods, and or services people use every day. Standards address a range of issues, including various protocols, to help maximize product functionality and capability, facilitate interoperability, and support consumer safety and public health. It is only through the application of standards that the credibility of new products and new markets can be verified. IEEE, that is Institute of Electrical and Electronic Engineers, is a leading developer of industry standards in a broad range of technologies that drive the functionality, capabilities, and interoperabilities of products and services, transforming how people live, work, and communicate. Now, we have come to the main topic, that is IEEE 802.11. IEEE 802.11 standard, popularly known as Wi-Fi, lays down the architecture and specification of wireless LANs (WLANs). The IEEE 802.11 standard consists of a series of technological advances that have been developed over many years. Each new advancement is defined by an amendment to the standard that is defined by identified by one or two letter suffix to 802.11. It is common to hear people refer to 802.11 standard or 802.11 family of standards. However, to be more precise, there is only one standard, IEEE 802.11 2007, but many amendments. Commonly known amendments include 802.11a, b, g, n. In the rest of the video, I will explain in detail about each amendment. This is the original amendment. The specification is it allows 2 Mbps on only 2.4 GHz band. But the later amendment 802.11b added new coding schemes to increase throughput to 6 Mbps. 802.11a added support on 5 GHz band and orthogonal frequency division multiplexing (OFDM) coding schemes that increase throughput to 54 Mbps. 802.11g brought OFDM from 802.11a to 2.4 GHz band. 802.11n added an assortment of high throughput advances to increase throughput roughly 10 times, such that high-end enterprise access points achieve signaling throughputs of 450 Mbps. The emerging 802.11 AC standard promises to exceed 1 Gbps of throughput. The individual standards is used now are 802.11a, b, g, n, which uses a more advanced technology than others. The newest standard 802.11 AC and AX are the fastest standards. Now, IEEE 802.11a. IEEE 802.11a, also known as IEEE 802.11 1999, was an amendment to IEEE 802.11 wireless local network specifications that defined requirements for an orthogonal frequency division multiplexing communication system. Its specification is it provides protocol that allows transmission and reception of data at rates of 1.5 to 5.4 54 Mbps. Its purpose is it was originally designed to support wireless communication in the unlicensed National Information Structure bands. It has seen widespread worldwide implementation, particularly within the corporate workspace. While the original amendment is no longer valid, the term 802.11a is still used by wireless access point cards and routers manufacturers to describe interoperability of the system at 5.8 GHz, 54 Mbps. This picture demonstrates that this standard allows a wide range of speed, like 6 Mbps, 24 Mbps, and 54 Mbps. IEEE 802.11b IEEE 802.11b, also known as IEEE 802.11 1999, is an amendment to the IEEE 802.11 wireless networking. Its specification is that it extends throughput up to 11 Mbps using the same 2.4 GHz band. A related amendment was incorporated into the IEEE 802.11 2007 standard. It also uses the same CSME-CA media access method defined in the original standard. Its purpose is, due to CSMA-CA protocol overhead, in practice, the maximum 802.11 throughput that an application can achieve is about 5.9 Mbps through TCP and 7.1 Mbps to UDP. Technically, the 802.11b standard uses complementary code technique, keying, as it as its modulation technique, which uses a specific set of 8 complementary codes that was originally designed for OFDM, but also suitable for use in 802.11b because of its low autocorrelation properties. IEEE 802.11g IEEE 802.11g, also known as IEEE 802.11 2003, is an amendment to IEEE 802.11 specification that operates in 2.4 GHz microwave band. Its specification is the standard has extended throughput to up to 54 Mbps using the same 20 MHz bandwidth as 802.11b uses to achieve 11 Mbps. Its specification under the marketing name of Wi-Fi has been implemented all over the world. Its purpose is, in practice, access points may not have ideal implementation and may therefore not be able to achieve even 31.4 Mbps throughput with 1500 byte packets. This is because the available throughput is shared between all stations transmitting, including the AP. So both downstream and upstream traffic is limited to a shared total of 31.4 Mbps using 1500 byte packets and 54 Mbps rate. IEEE 802.11n IEEE 802.11n, also known as IEEE 802.11 2009, is a wireless networking standard that uses multiple antennas to increase data rates. Its specification is its standardized support for multiple input multiple output MIMO, frame aggregation, and security improvements, among other features, and can be used in 2.4 GHz or 5 GHz frequency bands. Its purpose is the standard is to improve network throughput over the two previous standards, 802.11a-G, with a significant increase in the maximum net data rate from 54 Mbps to 72 Mbps with a single spatial stream in a 20 Mbps channel and 600 Mbps channel operating with a width of 40 MHz are another feature incorporated into 802.11n. This doubles the channel width with 20 MHz in previous 802.11. This picture compares the speed and range of the all the different standards. BGN. We can very well see that 802.11n is very fast and it covers more distance compared to B and G. Now, IEEE 802.11 AC, IEEE 802.11 AC and AX are the latest standards and are widely used nowadays. IEEE 802.11 AC, also known as IEEE 802.11 2013, is a wireless networking standard in the 11th set of protocols, providing high throughput wireless local area networks on the 5 GHz band. Its specification is it has multi-station throughput of at least 1.1 gigabit per second and single link throughput of at least 500 megabits per second. This is accomplished by extending the air interface concepts embraced by 802.11n, wider RF bandwidth, more MIMO spatial streams, etc. Its purpose is new technologies introduced with 802.11 AC showed extended channel binding, which provides optional 160 MHz and mandatory 80 MHz channel bandwidth for stations. IEEE 802.11ax IEEE 802.11 AX, also known as Wi-Fi 6 and Wi-Fi 6E, is an IEEE standard for wireless local area networks and successor of IEEE 802.11 AC. It is also known as High Efficiency Wi-Fi for the overall improvements to Wi-Fi 6 claims under dense environments. Specification Its specification is it is designed to operate in license-exempt bands between 1 and 7.125 GHz, including the 2.4 and 5 GHz band already in common use, as well as the much wider 6 GHz band. Its purpose is this standard is enhancing throughput per area in high-density scenarios such as corporate offices, shopping malls, and dense residential apartments. This also translates 75% lower latency. The quadrupling of overall throughput is made possible by a higher spectral efficiency. This image shows the evolution of Wi-Fi. To sum up, the IEEE standards are industry standards that specify the functional capabilities and interoperability of products and services that people work in day-to-day life. IEEE 802.11 standard, popularly known as Wi-Fi, lays down the architecture and specification of wireless LANs. Its frequency was 5 GHz and its speed was 2.4 Mbps. There are many amendments in this standard. The most common ones are discussed here. A. Its frequency is 5 GHz and its speed is 1.5 to 5.4 Mbps. For B, its frequency is 2.4 GHz and speed is 11 Mbps. For G, the frequency is 2.4 GHz and speed is 54 Mbps. N, the frequency is 2.4 or 5 GHz and the speed is 600 Mbps. AC, the frequency is 5 GHz and speed is 0.5 Gbps. AX, the frequency is 1 to 7.125 GHz and the speed is 0.5 Gbps. Thank you.